Hi folks, welcome back to Math with Captain Rod. The purpose of this video is to demonstrate how to find the interval of convergence for a power series. So what we're looking at here is the sum from n equals 1 to infinity of 3x minus 2 over n, the 3x minus 2 being raised to the nth power. So what we're going to do here is we're going to apply the ratio test to this to analyze its convergence. So what needs to happen is the limit as n goes to infinity of, remember, a to the n plus 1 over a to the n. This has to be less than 1 for convergence, absolute valued. So what that's going to look like over here, we're going to have 3x minus 2 to the n plus 1 over n plus 1. And then we're going to be dividing by this, and I'm going to go ahead and, like I do a lot in class, and just move that over, turn the division into a multiplication. Right, and we need the limit as n goes to infinity of this to be less than 1. So we're going to take a look in here and talk about the limit first. Now, let's kind of group things together here. We got limit as n goes to infinity of n over n plus 1. And then these guys right here. Now, if we take 3x minus 2 to the n plus 1 up top, 3x minus 2 to the n, that product is just 3x minus 2. Because this is 3x minus 2 to the n times 3x minus 2. Now, when we take limit as n goes to infinity, this ratio here goes to 1. So this is equal to 3x minus 2. Now, for convergence, this limit has to be bound between minus 1 and 1. So we're going to write minus 1 is less than 3x minus 2 is less than 1. And again, this is coming from the ratio test fact that the absolute value of this has to be bound in this region. So what this is going to allow us to do here is this will allow us to find the interval for x. So I'm going to start by adding 2 to both sides. This is now going to read 1 is less than 3x is less than 3. And then we'll divide everything by 3. And this is now going to read 1/3 is less than x is less than 1. So 1/3 to 1 is called the interval of convergence. This series will be convergent as long as x is within this region, all right, by the ratio test. The radius of convergence is basically half the length of the interval here. Now the distance between 1/3 and 1 is 2/3. That's the distance between these. Half of that would be 2 over 6, or 1/3. So the radius of convergence is 1/3 for this series. Okay. Now, when you apply the ratio test, again, you always have to remember the ratio test is inconclusive when this ratio is 1. So what we're going to do is go back and say, all right, what happens if 3x minus 2 is minus 1? And then we're going to look at plus 1 on the other side. So if 3x minus 2 were equal to minus 1, this series is going to read the sum n equals 1 to infinity of minus 1 to the n over n. Now, we're going to discuss the convergence of this guy. Let me write it sum n equals 1 to infinity minus 1 to the n times 1 over n. Now, 1 over n is a divergent series. However, this is an alternating series. Because it's an alternating series, if it satisfies the 3 criteria for an alternating series, this thing could be conditionally convergent. So the 3 criteria, I'm doing this from memory. 1, these things have to all be positive, and they are. 1 over n is positive for all values of n starting at 1, getting higher. Second, this thing needs to be decreasing for all values of n after some, at least after some value, and they are. Just by observation here, as n gets larger, this thing's getting larger and larger, or as n gets larger, this gets smaller and smaller and smaller forever. And then third, that thing needs to go to 0 as n goes to infinity, and it does. So what can we say? This is conditionally convergent at x equals -1. So the original series is convergent in this region and conditionally convergent at, whoops, I'm sorry, that's not -1, it's 1/3. Because the value of x that corresponds to this -1 is the 1/3. So this series is convergent in this interval and conditionally convergent at x equals 1/3, based on the alternating series test. Next thing to do is we've got to look at the other endpoint, the right-hand endpoint, where 3x minus 2 is equal to 1. At that point, our series looks like the sum, n equals 1 to infinity, of 1 to the n over n. And 1 to the n is just 1. So this is the sum, whoops, I can write that a little better. Sum n equals 1 to infinity of 1 over n. And this is a divergent series. So, kind of summarizing our answer, what we know, our original series, our original power series, is convergent on this interval. The radius of convergence is 1/3. And it is conditionally convergent at x equals 1/3. So, hope this video helps demonstrate these concepts. Have a great day.